Hello everyone, welcome to Emmanuel tutorials. Today we will be seeing about how we will perform the steps for convolution using graphical method in continuous time, and for discrete we'll be seeing several methods to perform convolution. So first we'll go with continuous time. In continuous time what we'll be doing is, first there will be two signals, one is the input and one is the impulse response. So suppose one is x of t and one is h of t. Both will be some signal. This is for continuous time. So it is some continuous time signal in t axis. Now what we'll be performing as the first step is, we will be converting this t axis to tau axis. So x of t will become x of tau and h of t will become h of tau. So this will become, t will become tau, this t also will become tau, this will become x of tau and this will become h of tau. The next step is folding. Folding means the same as the reversal type of operation which we perform on signals. So what will be the thing is, any one signal you can fold. It can be x of t or it can be h of t. So here it will become x of tau and h of tau. So suppose we fold the x of tau part, it will become x of minus tau. And if you want to fold the h of tau, it will become h of minus tau. So an example would be, suppose we took x of tau, it will become something like this. X of minus tau. So any one can be reversed. The third operation is shifting. In shifting, we'll be shifting whichever folded signal we have used by t. So it will be x of minus tau plus t or h of minus tau plus t. So suppose we consider these limits as -1 and +1. Now we have reversed it, so this becomes, the smaller level becomes at -1 and this becomes +1. And when we are shifting this signal by t, what will happen is, the signal will be something like this: t -1 and t +1. So the limits just change by adding them with t. So this will be x of minus tau plus t. Now the next step is multiplication, that is any one. So suppose you have used x of t for shifting and folding, it will become h of tau into x of t minus tau, or if you have used h of tau for the folding and shifting operation, it will become x of tau into h of t minus tau. And then you'll perform the integration. Integration will be from minus infinity to plus infinity, h of tau into x of t minus tau d tau, or integration from minus infinity to plus infinity, x of tau into h of t minus tau d tau. Now we'll go to the discrete convolution part. It's the same thing here, but we'll have the n axis. So the n axis will get converted to k instead of tau. So this axis will be named as k, and x of n will become x of k. Similarly, h of n. And folding will take place on this k axis, so it will become x of minus k. And folding will take place on the k axis, so it will become x of minus k. Similarly, if you take h, it will be h of minus k. Then similarly shifting, here it will get shifted by n, so it will be minus k plus n or h of minus k plus n. And then multiplication, x of k into h of minus k plus n or h of k into x of minus k plus n. And then the summation will be k is equal to minus infinity to plus infinity, x of k into h of minus k plus n or summation k running from minus infinity to plus infinity, x of k or x of n minus k into h of k. So you can perform any one of the operations and any one of the corresponding expressions can be followed. Now we'll go to the example solving. So first we will go for continuous time example. So here we have taken x of t as minus e raised to minus 3t into u of t, and h of t is u of t minus 2. Now how will we draw this signal? E of e raised to minus 3t is an exponential signal and it is a decaying one. Something like this. And here the value is 1. And this is getting multiplied by u of t. So the signal, this part of the signal will not be there. Only this much part of the signal will be present. And this is t, this is x of t. And for h of t, u of t minus 2, that is shifting of the unit step signal by 2. And it is getting delayed by 2. So at 2 this signal will start. This is h of t. Now the first step which we'll be following is obtaining the limits of y of t, that is the limits of the convolution of x of t and h of t. So the final limits will be sum of lower limits and sum of upper limits, and t is between these two limits. So first we will see x of t and we'll find out what is the lower limit for x of t. For x of t, we see that the signal begins from 0. So the lower limit of x of t is 0. And for h of t, the lower limit is 2. So the lower limit of h of t is 2. So we will add both of them, that is 0 plus 2 less than t less than sum of upper limits, that is for x of t the upper limit is infinity because the signal is going to go till infinity. And for h of t similarly it is again infinity, so it is going to be infinity plus infinity. So we have obtained the limits, that is 0 plus 2 is 2, t and infinity. So t is going to lie, or x of t is going to lie between 2 and infinity. The next step is conversion of t axis to tau axis. So x of t, this will become tau, this will become tau, that is x of tau. And h of tau Now the next step is folding. So we can choose any of the signals for folding. So here we will choose h of tau. You can choose x of tau also. So if we fold the signal, it will be h of minus tau. Axis is tau, and this signal will become the exact opposite. That is, it will start from, or it will end at minus 2, and it will start from minus infinity. Now the next operation is shifting. We will shift the same signal that we folded. So this will become minus 2 plus t, or tau, and this will be h of minus tau plus t, or h of t minus tau. Now the next step is multiplication. Now we will multiply this folded and shifted signal with the x of tau signal. So we can draw that x of tau signal again over here. X of tau is the signal. We need to multiply these two. So first case that we'll consider is when this t minus 2 is less than 0. So what do we see when t minus 2 is less than 0? The multiplication of these two signals is from minus infinity to minus 2 plus t. We see that the signal is 1 for h of t minus tau, and for x of tau it is 0. So the multiplication of these two signals will be 0 for t minus 2 less than 0. So what we can write is y of t is equal to 0 for t minus 2 less than 0. Now the next case can be when t minus 2 is greater than 0. So when t minus 2 is greater than 0, what we can see is this signal will get shifted over, or h of t minus tau will get shifted over this x of tau. So we'll get some signal such as this one. This is x of tau into h of t minus tau. So it will get shifted over the signal. So this process is called sliding. So what we can see is that multiplication of this x of tau and h of t minus tau is not 0 in this case, because till here we see that the value of x of tau is 0 and this is 1. So 1 into 0 is 0. From 0 to t minus 2, this is t minus 2. So 0 to t minus 2, it is some finite value, because 1 is getting multiplied by this e raised to minus 3t u of t. So what we will obtain is the multiplication, that is x of tau into h of t minus tau, and this x of tau, what value it has is 1 in this limit, and the value of h of t minus tau is e raised to minus 3t. So in the last step, that is integration, we will be performing the integration of the multiplication of both these values. That is, y of t is equal to integration of minus infinity to plus infinity x of tau into h of t minus tau d tau. This is equal to integration. Now integration here we are considering only from 0 to t minus 2, because we have got the values from minus infinity to 0. So from 0, that is the lower limit will be 0, the upper limit will be t minus 2. X of tau is e raised to minus 3t or e raised to minus 3 tau. H of t minus tau is 1 in this duration and multiplied by d tau. When we perform this integration, what happens is e raised to minus 3 tau, the integration is e raised to minus 3 tau upon minus 3, and the limits are 0 to t minus 2. This becomes e raised to minus 3 t minus 2 upon minus 3 minus e raised to minus 3 into 0, that is e raised to 0 upon minus 3. So the final y of t is equal to e raised to minus 3 into t minus 2 minus 1 upon minus 3. Or this we can finally write as y of t is equal to 1, because this minus 3 will get negated with this, so it will become 1 minus e raised to minus 3 t minus 2 upon 3. Now there are certain important formulae or certain important expressions which we get by solving convolution, which can be used to simplify your expressions in performing convolution. So these are some of the important ones. X of t convolved with del of t minus t naught is equal to x of t minus t naught. So if you are convolving any signal with a shifted impulse, it will be the shifted signal itself by the same shift amount. Similarly, if you are or convolving x of t with del of t, it will become x of t. And if you are convolving u of t, that is a step signal with another step signal, the resultant will be a ramp signal, that is t multiplied by u of t. This is equal to r of t. Now we will go to the discrete convolution example. Here we are taking the example of x of n as 1, 2, 3, 4. Here we have not specified the arrow such as this one. So the first value is at the origin itself. So this will be at 0. And for h of n we are considering 1, 2, 1, minus 1. So there are 4 methods which we can use for finding out discrete convolution. The first one is the array method, which is very easy. What you have to do is, you have to write the values of x of n on the horizontal line, makes this box kind of structure, and this will become x of n and h of n. Now what you have to start doing is, start multiplying each row element with all the column elements. So first we consider 1. So 1 multiplied by 1 is 1, 1 multiplied by 2 is 2, 3, 4. Similarly, the next one, 2. 2 multiplied by 1 is 2. 2 multiplied by 2 is 4. 6, 8. 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. Now to find out y of n from this, just write these curly braces. The first value of y of n will be, just draw these lines, slanting lines across the box. So the first value will be 1, comma, second value will be 2 plus 2, that is 4. 1 plus 4 plus 3 is 8. 10 plus 2 is 12. 12 minus 1 is 11. 11 minus 2 is 9. 1 and minus 4. So this is a very easy method to get the final convolution for discrete time example. The next method we'll be using is sliding strip method. So here we'll be writing this like this way: h of k is 1, 2, 1, minus 1. X of minus k is 4, 3, 2, 1. So what we have done is h of k we have written as it is. X is only or x is only folded. What we have done is, it was 1, 2, 3, 4. Now it becomes 4, 3, 2, 1. And sliding strip, that is, we are going to shift this or slide this x of minus k signal across this h of k and get the final y of n. So y of n will be, we'll write y of n. So the first value of this will be 1 multiplied by 1, that is 1. So this is the first value of y of n. Now the second value will be, you have to just shift this by one step. So it will become 1, 2, 1, minus 1. Now this 1 will go to 2. So this will be 1, 2, 3, 4. Now what we need to do is multiply 2 by 1, that is 2. Multiply 1 by 2, that is 2. And we have to add both these numbers. So here we are going to perform addition and this will become 4. So this is the second value of y of n. Similarly, you can continuously shift this and you will get the same values as we have done it with the array method. So this will become 1, 4, 8, 11, 9, 1 and minus 4. The next method is sum by column. In the sum by column method, we will be writing x of n and h of n as they are 1, 2, 3, 4 and 1, 2, 1, minus 1. And now sum by column, that is, each column we will be considering and finding the sums. So first we will be multiplying 1, that is the first value of h of n, by all the values of x of n and we will be writing it in the first row, that is 1 multiplied by 1, 2, 3, 4. So 1, 2, 3 and 4. Now the next one will be 2 multiplied by 1, 2, 3 and 4, that is 2, 4, 6, 8. Similarly 1, 2, 3, 4 and minus 1, minus 2, minus 3 and minus 4. Now the next step we will be performing is, we will be just adding the values. So for the first one, there are no values to be added, so we'll get that as it is. The second one, 2 plus 2, 4. Next, 3, 4, 1. That is 8. 4 plus 6 plus 2 plus minus 1, that is 10 plus 12, 2 minus 1, that is 11. 8 plus 3, 11 minus 2 is 9. 4 minus 3 is 1, and the last value is minus 4. So this is y of n. Then the next one we'll be going to is the graphical method. In the graphical method, we'll have to draw both the signals. This is x of n, 1, 2, 3, 4. H of n, 1, 2, 1, minus 1, minus 1. The first step we'll be performing is changing n axis to k axis, then reversing it, that is x of minus k. Then we'll be shifting it by n, that is 0 plus n, minus 1 plus n, n minus 1, n minus 2, n minus 3. Now we'll be performing the sliding method. So first, this is x of n minus k, and this is h of n, which we'll change it to k, that is this. So we will be using both the signals. So first we'll be multiplying these two signals. So if this n shift is less than 0, what will happen is when we multiply both these signals, the resultant will be 0. So for n less than 0, y of n is 0. Now for n is equal to 0, that is if this signal, that is the value of 1 goes to 0, this will be minus 1, this will be minus 2, this will be minus 3. So when we multiply both these signals, what will happen? We will, the values before 0 will be 0, because at this value it is 4, but here it is 0. Then again it's 3, again it will be 0, and this is at minus 1 it is 2, so it will be 0. But at 0, the value of x of n minus k is 1, and the value of h of k is 1. So 1 multiplied by 1, so the resultant signal will be this kind, x of n minus k multiplied by h of k. So this will be 1. And the next value will be at 1. At 1 we see that there is no signal present of x of n minus k. So it is 0. So 0 multiplied by 2, it is 0. And the rest of the signals also will be 0 valued. So for y of 0, we will get as 1. Similarly for y of 1, that is when n is 1, what will happen? 1, the value of n at 1 of, or when n is 1, the value will be 1. At n minus 1, that is at 0, the value will be 2. So this 2 signal This will be 2 multiplied by 1 over here, and at 1 it will be 1 multiplied by 2. So what will be the signal? It will be something like this. So we will multiply this. 0 value is 2 over here, so 2 multiplied by 1, so it will be 2, and 1 multiplied by 2, that is 2. So at 0 we'll have 0, or at 0 we'll have 2, at 1 we will have 2. X of n minus k into h of k. Here x, or here n is 1. So x of k, or 1 minus k into h of k is this value. So what we'll be doing is, to find out the value of y of 1, we'll be carrying out summation, that is 2 plus 2. This is equal to 4. We can observe that these are the same values we are getting as with the previous method, that is array method or sum by column or any other discrete convolution methods. Similarly, you can perform the other operations by just sliding it through until you get the value as 0 again. Thank you for watching the video. Please like, share and subscribe our channel for more such videos. Do watch our other videos.